Hey everyone and welcome! Today we are diving deep into the three-dimensional world that's all around us. You know, from the Amazon box on your doorstep to the soda can in your fridge. We're going to learn how to understand them using the language of geometry. So let's get right into it.
Have you ever actually thought about that? I mean, how much soda is really in that can? Or you're wrapping a gift and you're thinking, do I have enough paper for this? Well, these might seem like everyday questions, but guess what? They're actually geometry problems in disguise. And the answers lie in understanding two super important concepts: how much space something takes up and how much stuff it takes to cover the outside. And today, we're going to master both.
To get there, let's meet the stars of our show: the cube, and the cylinder. Seriously, these three shapes are the fundamental building blocks for so many objects we use every single day. And I promise, by the end of this, you're going to start seeing them absolutely everywhere.
So here's our game plan. We'll start with the basics, then we'll jump into how to measure the inside, that's volume, and then the outside, which is surface area. After that, we'll put it all to the test with a really cool real-world example. And finally, I'm going to leave you with a super handy toolkit so you can solve your own 3D puzzles.
Okay, first up, let's get our foundations solid. What are we actually talking about when we use these words volume and surface area?
Let's kick things off with volume. Put simply, it's just the amount of 3D space an object occupies. The easiest way to think about it is this: how much stuff can I fit inside? That's volume.
And then you've got surface area. This is the total area of all the outside surfaces of an object. So if you were going to paint a box, the surface area is literally the total space you'd need to cover with paint. All the sides, the top, the bottom, the whole shebang.
Okay, so let's get practical. How do we actually calculate the volume for our shapes? Let's talk about filling things up.
First up, the cuboid. This is your classic box shape, right? A shoebox, a book. It's defined by three simple measurements: its length, which we'll just call L, its breadth, or you could say width, which we'll call B, and of course its height, H.
And the best part is how simple the formula is. To find the volume of any cuboid, you just multiply those three things together: length times breadth times height. Yep, it's really that straightforward.
Next, we have the cube. Now, a cube is just a special, kind of perfect version of a cuboid where the length, breadth, and height are all exactly the same. Think of a single die from a board game, and that perfect symmetry makes its formula even easier. Since all the edges are equal, we can just call the length of one edge A, so the volume becomes A times A times A, or, more simply, A cubed. Simple, elegant, and really powerful.
And our final shape for volume is the cylinder. For this one, we just need two measurements: the radius of its circular base, that's R, and its total height, H.
Now, this formula might look a little complicated, but the idea behind it is actually so cool. See that first part, pi times r squared? Well, that's just the formula for the area of a circle, right? It's the area of the flat bottom of the can. And then the formula just multiplies that area by the height. So you're basically calculating the area of the base and then stretching it all the way up. This whole area of the base times height idea, it's a huge key to understanding volume for a ton of different shapes.
All right, we've totally mastered filling things up. Now, let's talk about wrapping them up. It's time to cover the exterior by figuring out surface area.
Okay, one really crucial point here. There are actually two types of surface area. There's lateral surface area, which is just the area of the sides. Think of the paper label on a can of soup, just the part that wraps around. But then there's total surface area, which includes the sides plus the top and the bottom. It's the difference between painting just the walls of a room versus painting the walls, the floor, and the ceiling. For what we're doing today, we're going to focus on the total.
So for a cuboid, this formula looks a little busy, but it's really just doing some simple addition. Think about it. A box has three pairs of identical faces, right? A front and a back, a top and a bottom, and two sides. So this formula just calculates the area of one from each pair: the top, the front, and one side, adds them all up, and then just multiplies by 2 to get all 6 faces. Pretty clever.
And the cylinder formula is also really intuitive when you break it down. Just imagine you unpeel the label from a soup can, and you lay it perfectly flat. What do you have? A rectangle. The area of that rectangle is just the can's circumference times its height. Then, you just need to add the area of the two circular lids on the top and bottom. That's all this formula is doing. It's adding the area of the two circle ends to the area of that wrap.
Okay, enough with the formulas by themselves. The real magic happens when we actually use them to solve problems. Let's move from just formulas to some real-world puzzles.
So check out this challenge. we've got this big rectangular metal block, and its dimensions are 50 by 64 by 72 centimeters. Now the plan is to melt it down completely and recast it into a whole bunch of small, identical cubes, and each little cube has an edge of 4 centimeters. So the big question is, how many of those little cubes can we make?
Now here is the secret sauce, the one key principle that makes this entire problem solvable. When you melt something down and recast it, the total amount of stuff, the volume, doesn't change. The shape can change dramatically, but the volume is conserved. This is the secret to cracking the puzzle.
So with that in mind, the solution is a really straightforward 3-step process. First, we use our formula to find the volume of the big block. Next, we find the volume of one of those tiny little cubes, and finally, we just divide the big volume by the small one. And the result? We can make exactly 3,600 small cubes from that one single block. I mean, how cool is that? It just shows you the power of these formulas.
We have covered a lot of ground, so let's pull everything you've learned together into a powerful, practical toolkit that you can use anytime you want.
And here it is, your geometry cheat sheet. On one simple slide, we've got everything you need: the shape, its volume formula, and its total surface area formula. You should definitely screenshot this or jot it down. This is your go-to reference for figuring out how much fits inside a box or how much paint you need for a cylindrical pillar. Keep this handy.
You know, we started with some simple questions about soda cans and wrapping paper, and we've ended up with a really powerful set of tools for understanding the world. So I'll leave you with this question. Now that you have the tools, now that you know how to measure the 3D world, what problems are you going to go out and solve? Thanks for tuning in.